Okay, hey Vicky, I thought that probably making another video quickly would be the best way to communicate your questions. So we'll look at 6.2 and then 7.5. So with 6.2, first thing is you've got an n value of 10, because we're looking at samples of 10. You've got a probability of 0.05, and there's two conditions under which the sample will be rejected. The first one is that there's, sorry, I need to look at the question. It's just here. Okay, so the first one is that there's fewer than 2 defective articles. Okay, so the first one is that you're looking at where there's less than 2, and then the second one is that you have found that there are exactly 2, but then you've taken a second sample of 10 and you found that you're looking at there being none in that. Okay, now it's a tricky one, because these are both the conditions under which you would accept the sample, not that you would reject it. So when you're looking at the probability the company is going to reject the delivered batch, you are going to have to convert some of these probabilities. Okay, so first, if we look at the part where we're looking at the probability where x is less than 2, okay, that's the same as the probability where x is less than or equal to 1. Oh, sorry, I accidentally put an equal sign there. Don't need that. Okay, so less than 2. So if we work this out, we go on the calculator. Okay, we're going to be using, turn it on. Okay, so we're going to be using binomial CD. Okay, we've got an x value of 1, probability of 0.05, and that's n. Sorry, n of 10. This is the other way around to my calculator. It's very annoying. 0.05. Okay, so we can work that out, and we get 0.9139. Sorry. So that is the probability that you would accept the batch. Okay, because you've got a probability where it's less than 1, so fewer than either 1 or none are faulty. So you would have a 91.39% chance of accepting the batch. Now, probability of rejecting the batch is obviously then going to be 1 minus that, so 0.9139, okay, which gives us 0.0861. Okay, so there's an 8.6% chance that you would reject it. Okay, if we then look at the second part, okay, firstly we're looking at probability where x is equal to 2. So our probability where x is equal to 2, okay, we're looking at equal to 2, rest all stays the same, and we have a 0.0746 probability there. And if we then look at the probability where x is equal to 0, because these are separate trials, so separate probabilities, and then to work out the combined probability, we multiply them, we get x is equal to 0. Okay, so we have 0.595987. Okay, so our probability of accepting that would be 0.0746 times 5987. Okay, 0.0447. Okay, and again, this is our probability. This is actually our probability that we're going to accept this, that we've got 2 times by the probability that we've got none that are defective. So we would accept this because there's no defective ones in the second case. But if we did have 2 that were defective, and then we checked and there weren't 0, okay, we would have 0.076746, times by 1 minus our 0.5987, which is 0.4013 probability. So that then gives us 0.746 times by 0.0746 times by 0.4013. Okay, so this would be 0.0299. Now that's the probability that we would reject this, because we found that there's 2 defaulty in the first sample, and then we found that there's more than none that are defaulty in the second, that are faulty in the second sample. So our total probability is about 3% for that one. Okay, so that means that our total probability of rejecting the sample is 0.0861 for the first one. So that's where there's any more than one faulty item, plus the probability that there's two faulty, and then that we take the second sample and there's more than one that are faulty there. So 0.0299. Okay, so overall our total probability is 0.116. Okay, now I know this is slightly different to the answer that I showed you before. I was just thinking about it earlier and I realized that I hadn't done the inverse probability for this part here. Okay, so you might have got this as an answer or something, reasonably close to this, and you're probably right and I'm wrong. Okay, all right, so for question 7, I'll just quickly rub this out. Okay, we'll just leave that bit at the top. Okay, so for question 7, we have, this is the one with the multiple choice test. Okay, so we had n as 18, probability of a quarter, and he passes if he gets more than half the questions correct. So he passes, actually, do you know what? I think I did this as greater than or equal to 9, but it should actually be greater than 9, shouldn't it? So we should be looking at the probability where x is greater than or equal to 10. And that would be, yes, sorry, I didn't read that properly when I was doing it the first time. Okay, so for the second part of the question, we have, after the test, he reckons that if he's done a little revision, there are 4 questions he would have definitely gotten right, and that he would have been able to eliminate one of the wrong answers in each of the other 14 questions. Okay, so from that, we can deduce that, we now have a new value of n, which is 14. Oh, that's weird. Okay, we now have a new value of n. Why is it doing that? It's so weird. Okay, we now have a new value of n, which is 14. Okay, and we also have sorry, I think my computer's having a moment. Sorry, Vicky, no idea what happened there. Okay, so now we have a new value of n, which is 14, and we also have a probability which has changed to a third because he can able to work out one wrong answer in each of the questions. Now, we know that there's 4 questions that he already has got, so if he needs to get at least 10 questions right, that means that of these 14, he has to get more than 6 correct. Okay, so we're looking at the probability where x is greater than or equal to 6, which is 1 minus the probability where x is less than or equal to 5. Okay, so then we can put that in. So 1 minus probability x is greater than or equal to 5. So let's go into here, 7, 1, okay, variable. Okay, so we got 4, no, we're looking at 6, no 5 isn't it, 5, 14, okay, and 1/3. If I do a fraction, does that work? Yeah, 1/3, 1/3. Okay, so we can work that out. We get 0.6898. Okay, so if we go back to our calculation menu, oh, what's happening? Okay, then 1 minus 0.6898 gives you 0.3102. Okay, so that is our chance that he gets more than 6 correct and therefore passes the test. Now, I think for the last question, I think it said you had to say whether there was that it was 50 times more. So if you did this probability divided by the old probability, that should be about 50 point something, okay, as a solution. All right, so I think I did, I mean, I've obviously made 2 mistakes there. One with the, I think, using 4, I think, instead of 5. And then for the other one, I'm not doing the 1 minus. So you might have got the right answers for these, but if you haven't, still, and you weren't kind of really sure how to do it, then hopefully this video helps a little bit with that. Okay, all right, talk to you later, bye. Any more questions, feel free to send them through.